Hello, everybody. In the first place, hello. Good afternoon for the European or good morning for Canadians. So I'd like to thank first to the ADASS committee for inviting me to talk in this really reference conference for the astronomy people. So my name is Monica Fernandez, and after several years working in domains like telephony or logistics, I arrived to ESAC, this in Madrid, more than 15 years ago in order to participate in the implementation of the ESAC Science Archives. In this presentation, I like to talk about the long path between the first archive that was published in 1998 and the latest one, and specifically, I like to talk about the Integral Science Archive. I will describe this evolution, but stressing the balance of two main drivers, that is the technology and the associated science. We will see how important is using the latest technologies if we want to have a really maintainable and usable tool that can fulfill the science use cases. So let's start our trip by talking a little bit about the mission, about the Integral. That is an international mission that has contributions from Russia with the Proton rocker and with the NASA Deep Space Ground Stations. It was launched in 2002, and at that time, it was the most advanced gamma rays laboratory ever created. And this allows astronomers to understand how matter behaves in extreme conditions. It's still in operations, expected to be until 2029. I will talk a little bit about this later. And it was the first spacecraft that could observe objects simultaneously in gamma rays, X-rays, and visible light. And the main goal is tracking violent events across the universe. In the slide, we can see the main targets of the missions, and I can highlight the black holes or the supernova explosions. I think it's a curiosity that the Integral payload was the heaviest science payload ever placed by ESA at the time it was launched. But why? Because the detectors have a really large area and a shield to protect those detectors from the background radiation. It has 4 aligned instruments, 2 gamma rays and 2 monitors. And it's worth it just to mention that the mission has an elliptical orbit around the Earth of 3 days. And this guarantees long periods of observations away from the radiation of the Earth. But in order to enlarge the life of this spacecraft, the spacecraft was approached to the Earth in 2015. And this allows to enlarge the life of Integral until 2029 in principle, of course. So science. I am talking about implement the Science Archive. I think it's worth it just to define somehow which is a science archive, and this can be considered like the final repository of the products originated for all the mission or the different missions. The goal is not only keeping the data, it's not only a storage, but it's as well a tool that allows to exploit the data, to exploit the scientific data. Those data products are regularly ingested through automatic process that we call ingestors, and we store data and metadata in files repositories and databases. We will talk about the databases that we have chosen. The minimal capabilities that archive has to have is data metadata retrievals using browsers, standard browsers or shell scripts, but as well, most of the following capabilities are now part of the core of the modern ones. We offer a lot of interactive plots. We allow interconnectivity with external applications. We are working really hard in implementing AstroQuery Python modules, or we plan as well to integrate all the archives with the Data Labs. Data Labs is a platform to exploit the data scientifically, and it is currently implemented in ESAC Madrid. So, but who is behind the archives? As I said in my introduction, it was not until 1998 that ESA published the first archive for the ISO mission. And from that moment onwards, ESAC was the default location for the European Space Agency for the scientific archives and the visual of the observatory activities. ESDC, that stands for ESAC Science Data Centre, is a team composed of both scientists and software engineers that are in charge of those archives. Our main strategy is reusing the manpower, the software, and the technology, because we want to ensure as well the long-term data preservation once the missions are completed. So the challenge is important because we have to support different types of missions that belong to areas so different like the planetary, astronomy, or solar. We have to support different type of data for different user communities, and everything using a common architecture and a common branding as well. So along these years, the team ESDC try to follow the latest technologies, and this has resulted in several generations of archives. So in the table, this table summarizes these details in the architecture. So, and this proves somehow the commitment that we have with the state-of-the-art technology. So if we go from bottom to up, we see that we started using commercial databases like Oracle or Seabase, but just to move quickly to Postgres because multiple reasons, like it is an open source, so we reduce costs, is community driven, so this means that bugs are fixed without delay, it's a secure system, but when missions like Euclid or Plato appear, PostgreSQL seemed not to be enough. So Greenplan was selected as a best approach to manage this large amount of data. So the strategy of this type of databases is distributing data and processing workload, but among several servers. One of my colleagues will talk about the databases in this Friday, the science conference. If we go up in the table, we see that the ingesters that are responsible for storing data metadata have evolved from being Java standalone applications to be based on Apache Camel framework. This is really an integration framework that allows to make the applications easier, avoiding a lot of boilerplate code. And as well as it is based on, it's really modular, it allows an important scalability that we need mainly for these missions like Euclid or Plato, that we are going to handle the large amount of data. In the server layer, we have not changed a lot technologically talking, because we are using a Java server open source based on servlets, but in the last generations, we are more focused now in implementing standards that belongs to international alliance like IBOA. So almost all the archives have TAP, that stands for Untable Access Protocol, that supports languages like the ADQL and are able to expose databases schemas, not to the final user. And finally, we can see that there a significant evolution happened in the client layer. We started the archives with Java desktop applications. The limitations of these Java desktop applications in the client part were overcome by using Java Web Start. But when the web technology started being more advanced, we moved to the Google Web Toolkit, and we noticed that as soon as we adopted this technology, the accesses to our archives had increased a lot. Finally, in the last generation, we selected Angular as the user interface framework, because we thought that it fit the team needs. And even we are considering to migrate some of the old archives, but we will see in detail later on which are the reasons behind this selection. So another step forward, apart of being committed with the technologies, happened when we started to use the UX design paradigm. But I think it's important just this term was invented by Don Norman in 1995, and it defines the whole process to build products, but focus on the quality of the user experience. I think it's really important to distinguish between UX and user interface and usability. That is a quality attribute of the user interface. that measures how easy is a user interface is to use. In this case, UX is a broader term because it involves the design on the entire process of acquiring and integrating the product, covering 3 important questions. And in the following order, in the first, we have to answer the why. So that means the user motivations to accept this product. And it can be because of the utility of the project, or even that because the ownership of the product is associated to something interesting. The second question is what, that addresses what can be done with the product. So they have the functionality, and finally the how, that covers the design of the functionality. So applying this paradigm to Integral was a really collaborative activity between scientists and software engineers. And so the first task was answering this why, by finding possible reasons a potential Integral user archive would have to visit the Integral archive. And the following answers appear, like having a different approach for distributing data, something that breaks the current solutions, increasing the visibility of the ESAC Science Archive, or attracting more people interested in the integral science. With this goal in mind, the second step was deciding what is the product about. And in this case, we conclude that we have to have an efficient and intuitive scientific tool to deploy the integral data. And finally, we put on the table which is a strategy to get this product. And so we started by replacing like the old forms-based user interface by a science portal. So we now organize the archive in science portals that are sections dedicated to specific scientific products. I mean, this does not mean that we don't use the forms anymore, but not as a central key, but a simple mechanism to refine the searches. We have included as well a sophisticated search engine to expose the database contents. We have engaged more than ever the relationship between scientists and engineers. We are using the ESA branding not only because we're implementing ESA archives, but as well because of the important benefits of branding, that is the customer recognition or loyalty, the consistency, or the credibility. We have put as well a special care in having a responsive user interface, that is basically the availability of a website to adapt to the size of any device. But on top of this, we must ensure that all contents look fine. And finally, adopting Angular as the UI framework, because we have seen that the technological solutions are key if we want to build robust and usable applications. So let's see the reasons behind selecting Angular, because I think it's worth it. It's a key point in this new archive. So a couple of years ago, we made an analysis of the more used technology in the client layer. We concluded that JavaScript should be the way to go for several reasons, like it provides faster user experience because it has brought user interactivity to the web, or because it provides good responsive web design, or because it has a really big community behind. So, and within the most popular frameworks, we choose, I mean, we have selected 3 specifically, React, Vue, and Angular as the most popular at that moment when we made this analysis. And we selected Angular for several reasons, like it is a complex framework, it's not a library, and it defines a complete project structure, and it's really convenient for large teams like ESDC. Google is behind, so this ensures long-term support. This is based on TypeScript, and that makes more robust applications and less prone to errors. It follows the model view controller paradigm that works better with complex applications. It has a very large community of developers, so any problem or any bug that may appear in one Angular application will be solved soon. And finally, because of its scalability, Angular is a modular base, and this means that for the archives can be reused, the different modules between them. So, okay, all this talk until now had led us here, at the Integral Science Archive. That it has been the first archive used in Angular, and that has followed strongly the principles of the UX design. As I said before, the user interface is organized in 5 science portals, covering 5 important topics that we will see now one by one. And as you can see in the slide, the look and feel is pure ESA branding. And the responsiveness has been one of the usability aspects that we care of much. So if we start with the 5 portals, the first one is dedicated to the black holes. And why? Because it was one of the main targets of the mission. Are the most important sources that populate the high energy sky. And why is one of the main targets of the mission? Because multiple reasons, like the unique combination of instruments that are sensitive to the X-rays and gamma rays, because of the very large field of view of 30 by 30 degrees, because of the for the orbits of 3 days, and for a high sensitivity of the detectors. In this section, we show explicitly all the black holes detected by the spacecraft. And for any of them, we offer as well 2 types of plottings that are the observation timeline and the time series that corresponds to all energy bands of the 3 instruments that are IBIS, TMX, OMC. The second portal is devoted to the integral reference source catalog that contains all the high energy sources. I mean, we have had several versions, but the latest one contains about 2,400 sources. In order to be able to facilitate the source searching, we have added an autocomplete search field. And like in the black hole portal, we offer 2 types of plots, the effective exposure and the time series. The third portal is still under construction and is dedicated now to the active galaxy nuclei. And just for curiosity, scientifically talking, this can be considered as a extremely bright region of a galaxy that emits really a huge radiation produced by a supermassive black hole. Why do we have a dedicated portal for those? And this is because as they are so luminous, they can help in finding distant objects. In this section, we group the sources in families, and like in the other portals, we offer several plottings. And on top of the ones that I already commented, we added some specific AGM products like the average spectra or the luminosity. 2 more portals will be implemented in the coming months that are dedicated to pulsars and nucleosynthesis, but still under construction. Okay, so I think at this point it's clear that what is this presentation about, and it's just to describe all the capabilities that the Integral Archive makes a meaningful experience. So that's the reason that I like to talk a little bit about the search capability and the result display. Based on the ESA branding, we have added an autocomplete search field located in the header website, and this allows quick search from everywhere on the application. This is a simple shortcut to a dedicated section that contains a smart search engine. This search engine tries to be a kind of Google-like and accepts multiple input patterns. So though at the beginning we thought about using regular expressions to process these patterns, at the end we discarded this because of the difficulties to maintain. So the solution was considering those filters as a formal language and creating a grammar using Unclear.
Monica, 5 minutes.
Okay, thank you. So a JavaScript widget called tabulator is used to allow the results in tabular format. We have used this tool or this library because of mainly because of this performance, and the The reason why it's so performant is that it only renders the visible rows. Okay, so in parallel to the metadata display, we as well show some graphs because we think that are really meaningful products, and we have selected two types of libraries, that is the GS9 and the Plotly. The GS9 is really an interesting library that is the successor of the DS9, and we use it to display the mosaics of integral. We display the 3 RGB bands, and we are able to merge thanks to the capability of this interesting library. And Plotly is another library that we use with really interesting results. Okay, finally, I like to emphasize that ISLA, Integral Archive, has taken the lead in adopting some of the improvements covered in this talk, like using Angular, like replacing archives form-based approach by Science Portal, or by integrating the astronomical GES library. So these kind of initiatives are key. We want to evolve the science archives. And it is the first step in the birth of a new generation of archives. So missions like Hubble, H3 or SOHO have already followed this step, but several more will start soon. So let's conclude this talk with a quick summary. We have seen that the ESDC is a group of scientists and engineers working together to implement a science archives. That is a really important tool that enables the maximum scientific exploitation and an efficient long term. We have seen that the commitment of the team with the technology result in several generations of archives, but only with one goal, that is improving the user experience. We have made a tour along the ESDC history, starting with ISO in 1998 and ending with the head of this talk, the Integral Archive. That is a pioneer in several aspects, like putting a special effort in engaging the mission scientists, following the UX design paradigm, or selecting the Angular framework. We plan to release this archive in the coming summer, unless that something strange happens. And finally, we have seen how ISLA has inspired other archives, though this list doesn't end here. Like a planetary James Webb or XMM will come soon. Thanks a lot.
Thank you very much, Monica. That was very interesting talk, interesting project.